Good evening friends, welcome to the online presentation of maths. Now in this video we will talk about angular bisector. Now before talking about angular bisector we will see about what do you mean by when you say the distance between a point and a line. Okay. Now suppose I have any arbitrary point, say C, and there is a line, ray or segment, whatever you call. Let's see as this point as A, this point as B. Now if you have to find out the distance between this point C and a line, then which distance should you take? I mean, are we talking about this distance, this distance, this distance, this distance? Which distance are we talking about when we have to take the distance between a point and a line? And this is quite confusing, because to find out the distance between 2 points is very easy. Because suppose if we have 2 points, say X and Y, the distance between the 2 points is pretty straightforward, and if we join these 2 points, this is the shortest distance, and the distance between X and Y is the line joining these 2 points. But when you have to find out a distance between a point and a line, then you really don't know कि हम किस distance की बात कर रहे हैं, because there are infinite number of points on this line. Okay, now whenever we talk about distance, we always mean about the shortest distance. We always mean the shortest distance. Now the distance between a point and a line, the shortest distance between a point and a line is the perpendicular dropped from the point over the line. Now this is the shortest distance. This is the shortest distance between a point and a line, which is perpendicular to the line. Now you may ask why this is to be the shortest distance. Why not any other point? Let's call this point as F. At F के अलावा कोई भी अगर हम और पॉइंट लेते हैं तो वो शॉर्टेस्ट डिस्टेंस क्यों नहीं होगा? तो अगर आप कोई भी पॉइंट लेते हैं अदर देन F, सपोज इफ वी टेक दिस पॉइंट, से वी कॉल दिस पॉइंट एज G. अगर आप इस पॉइंट को G पॉइंट को लेते हैं, एंड इफ यू लुक एट ट्रायंगल CFG, देन एनी पॉइंट अदर देन F विल ऑलवेज बी द हाइपोटेन्यूज. अगर आप F के अलावा कोई भी पॉइंट लेते हैं तो वो हाइपोटेन्यूज होगा, एंड वी नो दैट फ्रॉम द पाइथागोरियन थ्योरम दैट हाइपोटेन्यूज इज द लार्जेस्ट साइड. अगर आप इस पॉइंट को लेते हैं, सपोज इफ यू हैव टेकन दिस आर्बिट्ररी पॉइंट से L, तो CFL will be a right angle triangle where CL will be the hypotenuse and FL will be the base, and CF will always be the perpendicular. Therefore, the shortest distance between a point and a line is the perpendicular dropped from the point over the line, and no other point will be the shortest distance. Okay, I hopefully that it has given you a decent sense of why the shortest distance will always be a perpendicular drop from the point. Okay, now let's keep this out of the picture and let's see what is angular bisector. Okay, I'm rubbing. Now suppose if I have a line, a ray, or segment, whatever name you give. Let's say this point is A, this point is B, and this point is C. Now these two segments are meeting at a point, we have named it as B. Okay, now what is an angular bisector? Now angular bisector is basically a line or a segment or a ray, whatever name that you give. It is a line which divides the angle into two equal parts. Now suppose if this is, we call this an angular bisector, and let's say this is a point, let's see as D. Okay, let's let me make it more proper. This. Okay, now this is a angular bisector of the angle B. Now since BD is the angular bisector, it means that this BD will divide the angle ABC into two equal halves. Now this angle will be equal to this angle. Therefore we can say that BD divides the angle ABC into two equal halves. Therefore BD is what? Angular bisector. Okay. Now what we have to prove in this video is that if you take any arbitrary point on this angular bisector, then that point will be equidistant from the two sides of the angle. Let's suppose we have taken point F as an arbitrary point on the angular bisector BD. Now what we have to prove that the distance between the side AB from F and the distance between point F and BC both are equal. And we have just seen what do you mean when we say that the distance between a point and a line, it is simply the perpendicular dropped from the point. Therefore if you drop a perpendicular, this is the distance that we are talking about. This is the shortest distance. Now let's call this point as G. I don't know, let's call this point as H. Okay, so what we have to prove in this video is FG is equals to FH. Okay, now that is not a very hard proof. Why? Because if you concentrate on the triangle FHB and triangle FGB, now you can say that this angle is equals to this angle. Now since these two angles are equal, therefore the third angle will also be equal. Therefore this third angle will also be equal. The side BF is common. So by invoking angle side congruency, we can safely say that triangle FHB and triangle FGB are congruent. If the two triangles are congruent, their corresponding side will also be congruent. So from here we can easily say that FH will be equal to FG. Hence FH is equals to FB. So what we have proved just now, that if you take any arbitrary point on the angular bisector, then that point will be equidistant from the two sides of the angle. Okay. Now please note it down so that I can rub it. Okay, now I am rubbing it. Okay, fine. Okay. Now let's go other way around. What I mean to say that if you take any angle, say ABC. Now if you take any arbitrary point, let's say D. Now what we have to prove, that any point which is equidistant from the end points, any point which is equidistant from the two sides of the angle, then that point will lie on the angular bisector. अभी हमने क्या प्रूफ किया है कि अगर कोई भी पॉइंट एंगुलर बाइसेक्टर पे लाई करता है तो वो इक्विडिस्टेंट होता है फ्रॉम द टू साइड्स ऑफ द एंगल. Here what we have to prove, that if there is an arbitrary point which is equidistant from the two sides of the angle, then that point will lie on the angular bisector. Now what do you mean by the distance between a point and a line? Now this is a distance, and now this is the distance between D and BC, and this is the distance between D and AB. Okay, now let's call this point as H. Let's call this point as G. Okay, now let's join BD. let's join BD. Okay, now what is given to us is DH, this point is G, DH is equals to DG, this is given to us. Now what we have to prove that point D lies on the angular bisector of angle ABC. Now again, it's not a very hard proof. Why? Let's see. Since this angle is equals to this angle, okay, hypotenuse, the BD is a common side which is equal to itself. BD is equal to itself. Okay. Now, this side is equal to this side. So by RHS postulate, right angle hypotenuse side postulate, we can clearly say that triangle DHB is congruent to triangle DGB, because if in a right angle triangle the hypotenuse and any one side is if hypotenuse and another side is congruent to the hypotenuse and another side of the another triangle, then those two triangles are congruent. So from here we can safely say that these two triangles are congruent. If these two triangles are congruent, then their corresponding angles will also be congruent. So therefore we can say that angle ABD is equal to angle DBC. It means that BD bisects the angle ABC. So it means that point D lies on the angular bisector of the angle ABC. Now, so what are the two proofs that we have seen? In the first proof we saw कि अगर कोई भी point angular bisector पे lie करता है, तो then that point is equidistant from the two sides of the angle. In the other way around proof, we saw that if there is any point which is equidistant from the end points from the two sides of the angle, then that point will lie on the angular bisector of that angle. Okay, so we will apply these ideas in triangle and find out some interesting ideas more. Okay, thank you so much.